Hello, U9. Welcome to a new topic. So this topic is called linear and nonlinear graphs. As you can see here, just a quick introduction is linear means straight lines. So we look at graphing straight lines as well as calculate problems involving linear patterns. Nonlinear refers to not straight lines. And because we're talking about graphing, we come back to using our good old friend, the Cartesian plane. Okay, so to get started, what we're going to do is look at how to calculate the length of an interval. So an interval can be defined as a section of a line with endpoints. And the endpoints help us name the interval. So as you can see over here, here's our line. It's defined with these two arrowheads on each end, and the interval is this purple section of the line with the endpoints A and B. So we actually call this interval AB, or it can be called BA. It's just we like things in alphabetical order, which is why it's AB. So how to calculate the length of an interval? Here we've got the 2 points, so P and Q, where P is defined as -4, 2. So remember, X comes first. So we go across to -4 and down to -2. And Q is 2, 6. So I just have to move that, to be honest. Damn it. Sorry. Q is 2, 6, which is all the way up here. That's Q. I'll just join the interval again. Okay, so what we can do is having a look. This is the length we want to calculate. If we have a look at these lines here and this line here, joining those two lines together, we form a right-angled triangle. With our right-angled triangle, we are able to work out this length of PQ by using the length of our hypotenuse. So this length PQ, right down here is our right-angled triangle. So to find our hypotenuse, which is the length PQ, we're going to need to know this length here and that length there. Now, because we're on a Cartesian plane, it's actually quite easy to work out what that length is. And I'm just going to call this corner, let's call it T. I'll do it in pink. Let's call that T. So the length PT, that interval across here, we can work out the length because all you have to do is count the grids, right? So from there it's 1, 2, 3, 4, 5, 6. So the length of PT is actually 6 units. And then the length of QT, and I'm just going to label that 6. The length of QT, again, you can count the units. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units. Now what we've formed is our right-angled triangle. And remember, for Pythagoras' theorem, let's call this length D for distance. All it is D squared is equal to the other two sides squared. So we've got PT squared plus QT squared. And we know PT has a length of 6 and QT has a length of 8. So then we've got D squared is equal to 6 squared plus 8 squared. Together that makes 100. But remember, we're not after D squared, we're after just the length D. So we have to take the square root, and the square root of 100 is 10. So what that means is the length therefore QT, PQ, wow. The length PQ is 10 units. Using Pythagoras. How easy is that? All right, the next one, just really quickly, we'll do this one this time. So again, we've got the points A and B. So on our graph, you can see A is up here, -2, 5, and B is 2, -2. Again, joining these two lines together, if you go all the way down until you get to the line B, and then you go across and join it again from B, again, you form a right-angled triangle. Let's just call this T again. So the length, we want the length of this side and this side. So AT what we can do is you can count the boxes, right? But what you also can do is if that's got a length of 5 and that's got a length of 2, well, like, because if you go from that's at 5 to 0 is 5, and then there to there is 2, so obviously that's 7. But it's exactly the same as taking the distance of 5, like finding the difference between these 2 points, right? So that's the point 5, and that's the point minus 2. If you find the difference between those 2 points, that becomes a plus because it's 2 minuses, and you get 7. So that's another quick way that you can do it without actually having to individually count all the grids. And then we've got BT this time. Again, we can take the difference between the 2 points. Notice that that's -2, and that is like 2. What if you go -2 minus 2, you're going to obviously get a negative number because that's just what it is. But because we're working with distance, even though it's going to be negative, the length can't be negative, so it has to be a positive, which is why you can actually go 2 minus, like do the reverse, do the highest number minus the lowest number, minus 2, that becomes a plus, which means that's 4. And as you can see, you can just count them. 1, 2, oh, what did I do? Oh yeah. Sorry, 1, 2, 3, 4, and then this is 7. Okay, so then the length AB, remember squared, is equal to AT squared. So that's the length AB. Up here I just called it D, but you can just keep it as AB, is equal to AT squared plus BT squared, which is equal to AT is 7, so 7 squared plus 4 squared. In total, that gives you 65. But we don't want AB squared, we just want AB. So you take the square root of 65, and you'll notice that in your calculator, that gives you not a whole number because it's a surd, right? So since this is a surd, usually the question might say leave in exact form. So this is exact form. Or it might say correct to say 2 decimal places, and then you're going to want to press it as a decimal, which is 8.0622, and then we can just round it, say, to 2 decimal places. Wow, I just said 2 things back the front. DP. Sorry about that. Okay, so that's how we calculate the length of an interval, which is super easy if you have a graph, right? Like you just draw a right-angled triangle and use Pythagoras. However, we are year 9 5.3, which means we do it without graphs. Or sometimes. Sometimes you'll have a graph, sometimes you won't. So, to kick it off, the formalities. The method for finding the length of an interval can be summarized formally into the formula blah, blah, blah. This graph looks crazy, right? So we've got the points. I'm going to explain it to you because as you can see here, you need to get used to this graph. So, all this graph is saying is you've got the points P and Q, right? This is the point P, this is the point Q. That is the interval PQ, right? And we'll just label it D for distance. Here we've got x1, y1 and x2, y2. And down here, because this is the length, this is the point T. Remember how we drew the line across and we just called that T, so we could define that interval as QT and PT. Well, as you can see, this keeps the same x coordinate as Q, right? Because if you went all the way down, that would be x2, which means that's T and Q both have the same x coordinate. And then because it's at that point, we call that's y1, right? Because if that's x1, y1, that has to be y1, which means T also shares y1. That's all it's saying. The reason why they're labeled x1 and x2 is to say that they're actually different x values, because we can't call it x and x because that would mean that they're actually the same value, which we know they're not, right? Here's an x value over here versus this one like down here. Same with the y. So we label it with y1 and y2 because they're different y values. All right, so if we've got these two lines, oh, what did I do over here? Yeah, this length, like I said, you can count the grids, but we don't have graphs. So we're going to not be able to count any grids. We're going to have to do it algebraically, which means that distance is the difference between the x points. Now, the reason why it goes x2 minus x1, obviously it's the same as x1 minus x2, but you run into that error of it being a negative value. So like before over here, if we did -2 minus 2, we would have gotten -4, and then you just have to realize, okay, it's distance, which means it's 4. Whereas if you do it this way, it kind of helps you. So the formalities. This length, PT, like I said, is the difference between the x values. And the reason why it's the difference between the x values is because this is x value x1 and this is x value x2. So obviously it's the difference between those two values there. Whereas this length QT is the difference between the y values because it's just that length shifted over here. So we have y2 minus y1. Here I've just said that it's x1 and x2 as the different notations, and y1 and y2 are the y values corresponding to x1 and x2 respectively. So the word respectively, the definition is pretty much just the order in order that's mentioned, right? So it says x1 and x2 respectively means x1 matches to y1 and x2 matches to y2. Now, this is just a whole lot of algebraic talk. It makes a lot more sense when we do it with a question. So going through, we'll have d squared equals pt squared plus qt squared because that's the length of the sides for, this is using, remember, this is Pythagoras. And we know that PT is the difference between the x values and QT is the difference between the y values. And then lastly, because we don't want d squared, we just want d, you take the square root. Ta-da! And magically you form this distance formula, which is exactly what we did on the previous page. Now, something to note is with the 2 points, it's really important that you keep the x and y points the same. So here, if this is the 2 points, right? If you're going to use the x coordinate from the first, if you're going to use this x coordinate first, you have to use that corresponding y coordinate first. If you're going to use this coordinate, this x coordinate second, you must use that coordinate second as well. There's no point in having x2 and then y1 here. It has to come from the same point. So whatever x value you use first, you use that same y value first. Now, in terms of this example here, where I was like, well, that's going to be a negative value, using the formula, that situation's actually sorted because you square it, which makes it positive anyway. So in terms of a picture, it makes sense to use the highest value first, but it really doesn't actually matter because you square it anyway, which is the beautiful part of maths, guys. So really quickly, using the distance formula. Here we've got the 2 points, -4, -2, and 2 and 6. And they're actually the exact same points that I used over here. So our answer should be 100. Using our two values, so we've got P is the points -4, -2, and I'm just going to let that be our x1 and y1, and Q is equal to 2 and 6, and I'm also going to let that equal x2 and y2. So for our distance formula, remember it's this guy, and this distance formula is going to be around forever. It's not going to go away, which is why you need to learn it, obviously. And because it's helpful, distance, good to know. All right, so then we leave our square root symbol. And because I've defined them, because I've defined them, I can just substitute them straight into my formula. But if you didn't define it, all you have to do is say, you take the x values. So let's color them in. Here's our x, here's our y. Oh, I've done them in the same color, it's going to confuse you. Here's our x, here's our y. Oh, actually, I think it's probably less confusing if I do this. Sorry. 1 point, another point. No, you know what? I'm going to can the highlighting. All right, so we take the first x coordinate, which is -4. And we're going to subtract 2. Because here's our first x and we've got our second x. Then we're going to plus, and because we took, oh, what have I done? I've labelled it wrong. I'm so sorry. Let's start again. Because I've labelled this x1 and x2, I should use it accordingly to how I labelled it, which means that this is going to be my x2, so I'm going to substitute in 2. This is what I'll do. So let's go. We've got 2 minus, and x1 is going to be -4. Now, notice, and I wrote it up here, the minus signs are part of the formula. That means that that minus does not, mean you can just leave that minus out. So we have to actually go minus -4, because it's that whole x1 point. And then that's all squared. Plus y2, which is this guy, so 6, minus y1, which is this guy. Well, that is not what I wanted. So minus, again, that minus has to stay in there, and we have -2, all squared. When you put all of this into your calculator, all underneath that square root symbol, if you leave the square root out for a second and put all of that in, you'll actually get 100, because that is 2 plus 4 is 6, 6 squared is 36, and then 6 plus 2 is 8, 8 eighths are 64. Put it all together, you get 100. Wait, did that make sense? Yeah. Wow, that was a lot. Yes, and then you get 10, which is what we got over here. How exciting is that? Okay, so if I ask you to use the distance formula, you can obviously do it without drawing a graph, which is the easy part. However, if there's a graph, it's nice and easy. You just make this right-angled triangle, and you can count them if you want. It doesn't matter. All right, good luck.